We'll start with a standard Elk Stack Docker image, then customize it for our netconf model-driven telemetry use case. Similar to our Puppet demonstrations from the previous module, we'll need to run this container on a larger computing instance. This is a T2 Medium EC2 instance in AWS, again similar to Puppet, because the minimum requirement for our Elk Stack is 4 GB of memory. Here's a snippet from the documentation that makes this clear. I've also created a public DNS hostname for this new instance named elk.njrusmc.net so that we can access it publicly. First, we need to install Docker and Docker Compose. I've included 2 scripts in the setup directory to assist with those tasks. We've explored both scripts in detail during a previous course where I introduced Docker. We need them again for this course, but we won't scrub them. The CentOS Docker install script does exactly what you would expect. It removes any existing Docker packages and performs a fresh install. The Docker Compose install script adds Docker Compose, a handy tool for orchestrating container setup and teardown on a single host. Let's run the CentOS Docker install script as root to get started. The script completed successfully and displays the current Docker version. Let's follow the recommended advice by running the Hello World container to ensure everything is functional. At the top, we see that our installation worked just fine as we can run containers without issue. Let's install Docker Compose to make things even easier for ourselves. We can run the other bash script using the command shown. This is a much faster installation and will simplify deploying the Elk Stack. Now, we can construct our customized Elk Stack container. Let's begin by exploring the Docker file. This file is quite simple because we start with a powerful base image. Sebastian Pujadas, or Seb P, maintains this image on his personal Docker Hub page, and it has more than 10 million pulls. The package is monolithic in that it combines all 3 Elk components into a single container, which scales poorly. We can't just add additional Logstash instances, for example, as we could in a true microservices design. However, this container is perfect for our use case because the components are tightly integrated and easy to configure. I'm adding myself as the maintainer for this custom image. This is usually a good idea whenever you create a new container or customize an existing one. Last, we have the actual customization. I'm not changing much. You may have noticed a file named 3tcpinput.conf in the Module 5 directory. This is a configuration file for Logstash that tells the service what kind of logs to receive. Let's quickly explore that file. The file begins with the word input because this defines another option on how Logstash can receive logs. If we were trying to determine how Logstash would send logs, we could use output. Logstash is already configured to send its logs to Elasticsearch, so we don't need to reconfigure that. However, we do need to tell Logstash to accept new logs on TCP port 5045 using JSON encoding. The default port for Logstash is 5044, which ties into an optional component named FileBeats, which we don't care about. I chose 5045 because it was the next port in sequence, but you could pick any available port. Our telemetry system is going to collect netconf notifications formatted as XML, change them to JSON, and send them to elk.njrusmc.net. This configuration file allows Logstash to properly receive those notifications. Using the copy command in the Docker file, we ensure that this configuration file is included in the container within the Logstash configuration directory. Rather than manually set up and tear down containers, let's use Docker Compose to make the process simple and repeatable. We can explore the dockercompose.yaml file to see how that works. First, we have to specify which version of Docker Compose syntax we are using. Given that we are on Docker version 19.3, we should use Docker Compose syntax version 3.7. Here's a chart that shows the compatibility matrix, which we covered in a previous course. Our services declaration is simple as we are only deploying a single container named Elk. We build this container from the local Docker file with a name of globoelk and a tag of latest. Then we specify a list of ports that should be published for external access. Here's a list of the TCP ports again, and with the exception of our custom Logstash TCP port of 5045, I've used the default ports for Elasticsearch and Kibana services. These concepts should all be a review. At this point, we've installed Docker and explored the source code required to build our container. Let's deploy the Elk stack in the next clip.